Okay, so we talked about the normal curve and normal distributions. Now we want to talk about scatter plots and correlation. Medical study finds that short women are more likely to have heart attacks than women of average height, while tall women have the fewest heart attacks. An insurance group reports that heavier cars have fewer deaths per 10,000 vehicles registered than do lighter cars. So what do we see here in both of these examples? We see a relationship in the first case between the height of women and their tendency to have heart attacks. In the second one, heavier the weight of a car and the number of deaths. So suggests what we call correlation, right? Because variation is everywhere, statistical relation. So in what sense? What are they talking about? Variation. Well, there's variation in the heights of women, and there's also variation in the number of heart attacks that women have, or the number of heart attacks in a group of women. So, and then the question is there a relationship between those two variations? Because variation is everywhere, statistical relationships are overall tendencies, not ironclad rules. They allow individual exceptions. Although smokers on average die younger than non-smokers, some people live to 90 while smoking 3 packs a day. To study a relationship between two variables, we measure both variables on the same individuals. Okay, so we're going to measure both. So if we're looking to study a relationship between two variables, for example, smoking and length of life, we measure both variables, how much they smoke and how long they live, on the same individuals. Right? We don't measure smoking on one set of individuals and how long people live on another set of individuals that we didn't measure the smoking on, that we wouldn't be able to establish any relationship in that case. We often think that one of these variables explains or influences the other. So you might think that smoking explains length of life or cancer or something like that. You don't generally think of it the other way around, right? You don't think that cancer explains smoking. Okay? So we talk about a response variable and an explanatory variable. So which would be the response variable? Cancer, or length of life, would be the response variable, and the amount of smoking would be the explanatory variable. A response variable measures an outcome of a study. An explanatory variable explains or influences changes in the response variable. So lots of examples of that. So if you're looking for a relationship, you might consider sort of making a picture of the data, and perhaps you'll be able to spot the relationship from the picture. So here we have what? State SAT scores. So SAT scores are some exam you have to take if you want to go to university in the United States, usually. Some people use average SAT scores to rank state or local school systems. This is not proper because the percent of high school students who take the SAT varies from place to place. Let's examine the relationship between the percent of the state's high school graduates who took the exam in 2002. So the percent of high school students who took the exam, who took the SAT, and the average SAT verbal score that year. We think that percent taking will help explain average score. So in other words, if you have a state where more people take the SATs, I guess they're saying that the average score should be higher. Therefore, percent taking is the explanatory variable, and average score is the response variable. We want to see how average score changes when percent taking changes. This is not such a clear or great example to start with, but let's do it anyway. So we put percent taking, the explanatory variable, on the horizontal axis, the x-axis, in figure 4.1. Figure 4.1 is the scatter plot. Each point represents a single state. Okay, so let's look at it. Okay, so we have along the x-axis the percent of high school grads taking the SAT. So, you can look at a state, and maybe in some state, only 10% of the people take the SAT. Or in some other state, maybe California, I don't know, maybe a lot more people take the SAT. A lot higher percentage. Okay, and then along the vertical axis, we have the SAT score, or actually the verbal score. Okay, so, and the dots represent the states. So for example, this dot here is for Colorado. And apparently, the percent of high school students taking SATs is what? About 28? They say 28%. And the average score is, of those 28%, is about 550 or 543 actually. Okay? So they say in Colorado, for example, 28% took the SAT, and the average SAT verbal score was 543. Find 20, okay. So this is the scatter plot for all of the states, not just for California. And we see a kind of relationship between the mean SAT and the percent of high school grads taking the SAT. What happens? As the percent of high school grads taking SATs increases, we see actually that the mean SAT score is decreasing. So actually it's just the opposite of what we thought, or what was the supposition was. So that was called a scatter plot. A scatter plot shows the relationship, if there is any, between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, the values of the other variable appear on the vertical axis. Each individual in the data appears as the point in the plot. Okay. Always plot the explanatory variable, if there is one, on the horizontal axis, the x-axis. Okay, all right. So what do you do when you look at a scatter plot? In any graph of data, look for the overall pattern and for striking deviations from the pattern. You can describe the overall pattern of a scatter plot by the form, direction, and strength of the relationship. An important kind of deviation is an outlier. Okay. Figure 4.1, the figure we saw before, shows a clear form. There are two, is that right? 4.1. Is that the one we saw before? Yeah. So they're saying not only can you see a kind of decreasing pattern here, but they're suggesting that there's sort of two groups. There's a group here and a group there. In the cluster at the right of the plot, 52% or more high school graduates take SAT, and the average scores are low. The states in the cluster at the left have higher SAT scores, and no more than 36% of the graduates take the test. There are no clear outliers. That is, no points fall clearly outside the clusters. What explains the clusters? There are two. So if you look at that scatter plot, besides looking at that trend that I suggested, you can also notice that there are these clusters. And of course, you'd say, well, what are these? Why are these clusters there? So what explains the clusters? There are two widely used college entrance exams, the SAT and the ACT. Each state favors one or the other. The left cluster in figure 4.1 contains the ACT states, and the SAT states make up the right cluster. In the ACT states, most students who take the SAT are applying to a selective college that requires the SAT scores. This select group of students has a higher average score than the much larger group of students who take the SAT and the SAT states. Okay? All right. Then they say that the relationship in figure 4.1 also has a clear direction. States in which, this is what I said earlier, states in which a higher percent of students take the SAT tend to have lower average scores. So, right, you could see that it went from high to low as you move from left to right. So this is called a negative association between the two variables. Because if you drew a line to represent the data, that line going from the top left to the bottom right would have a negative slope. So the association is called negative. And also the way we measure it, it turns out to be negative. Positive association. Two variables are positively associated when above average values of one tend to accompany above average values of the other, and below average values also tend to occur together. All right, now the next thing is going on here. The strength of relationship in a scatter plot is determined by how closely the points follow a clear form. The overall relationship in 4.1 is not strong. Let's see if we have anything better here. Okay, whatever this is, there's a negative association between the two variables. By the way, they also mention how you can add in an extra variable to a scatter plot, and in particular an extra categorical variable to a scatter plot. So let's look at this picture again. I guess it's the same picture. Percent of high school grads taking SATs and mean SAT verbal score. And that's the same picture, but now we have some color, and what the color represents is another variable on the same set of individuals. Or remember, the individuals were the states in this case. But anyway, on the same set of individuals, we're going to record a third variable about that individual, about that state. So we already have shown, we've already recorded two variables, the percent of high school grads taking SAT and the mean SAT score. We've already recorded two variables on each individual, on each state. Now we're going to talk about a third variable on that state, and that is whether it's a southern state or not. So I don't know, blue might represent it is a southern state, and orange that it's not, or vice versa. So let's read what they say here. But anyway, the idea is that we have a way to picture a third variable, even though it's only a two-dimensional plot, in the case that that third variable is a categorical variable. In this case, the categorical variable is southern or not southern. And so we can just use a color, two colors, to indicate one or the other. Okay, I'm going to stop here and come back to it afterwards.